This is lesson 2, and again, if you haven't printed this out, you might print it out. However, the general plan or the general idea is going to be that you watch the whole video and then you go back and re-watch it as necessary when you're going through the actual lab. It's probably going to be better if you watch the whole thing first and then you have a good idea of what you're going to be doing. So in this lesson, it is on Ohm's law, and we're going to be using much of the same circuit that we did last time. That's why I said that if you wanted to leave it assembled, then you wouldn't have to reassemble it. So I'm going to show you here, I'm going to use the same resistor that I used before, which is not the same one that you're using. You should be using a blue, or a green, blue, orange, and I'm still using my yellow, violet, orange, so I will have different numbers. The other thing that I realized is that both of our meters have a little thing on the back that if you want to stand them up, that you can do that, which I will so that you can see the numbers better. So if we look at our circuit, I still have the resistor there. We're going to be collecting current and voltage data. So I'm going to reconnect my meter to measure current. It says to measure the resistance, and there's a few questions about that. It probably should be the same as it was when you did it the first time, but if you want to remeasure, that would be okay. So now I'm going to connect the black terminal over to the ground wire and the red one to the resistor. So this is where the circuit is open, because remember before I had this in the same row with the resistor to make a complete circuit. So I took that apart and I just put the meter, the ammeter, in where I had it before. Now I'm going to turn on the circuit board. So you should always remember to turn off the meters and the circuit board when you're done for the day. So I'll turn this back on. Notice we have the two little lights here to show that it's on. I have to turn the meters on, and we're going to be measuring current. And if I look at my paper, I believe that it says to do this with milliamps, the 2 milliamp scale. It might be better to turn this back off and set the dials on both meters before you turn the circuit board on. I don't think it really hurts if you switch dials, but it would just be better to have them in the right place. So we're going to turn this over to the 2 milliamps. So it should show 0, which it does. And we're going to turn this one on, and we're going to leave it at the 20 volts, which is what we had last time. Okay, now we're going to turn the circuit board on, and we had left the dial, this knob up here, the same place, so it shows 4 volts. If you look at the table on page 5, it tells you to start with 8 volts and then decrease by 2 volts, also getting some negative values. So we'll look at the negative ones in just a minute. So you'll want to start up here with 8. So you adjust it up to about 8. Again, you probably will never get 8 exactly, so if you're pretty close to 8, 8.04 or 03, that's fine. Then over here, notice we have 0.174 milliamps. So you would record that in the first set of boxes there. And then you would turn it down till you have 6 volts, and get about 6, and record the current. Then on down to 4, about 4, and then on down to about 2. Oh, there's about 2. Then let's think about if we want 0. If we have 0 volts, a fairly simple way of doing that would be either turn the power supply off or disconnect something, but if you have 0 volts, you should have 0 current, so you can just put the zeros there. Now the question is, how do you get negative voltage? Well, the simple way is to interchange the leads that go to the ground and the positive. There are several ways you can do it, but I think this is going to work the best. And if we do that, then our meters, we can just leave everything else connected. So I'm going to turn the circuit board off. I don't think it would be necessary, but I'm going to do it anyway. So I'm going to undo the little red wire here and the black wire here and just switch those and put the black one into the yellow, which is the positive, and then the red wire into the ground terminal. There we go. So I'll connect that. Okay, now when I turn this back on, let's do that, and we should see a negative voltage as well as a negative current. So that was kind of what we were after. So we have the -2, and then we turn the knob up until we get -4, -6, and -8. Where that is. Okay? So that will be the data, and then we're going to look at analyzing the data. So what I want to do now, in anticipation of the next part where we'll be using a light bulb, I'm going to turn this voltage down, and I'm going to switch these back to the way they were so that we have the ground in the ground. Whoops, you have to get it in. Okay, there we go. And then the red one goes back in the yellow that has the positive terminal, positive voltage. So we can verify we have a positive voltage, positive current, and then we're going to turn this off. Okay? Now, it says to plot a graph, and there are several things about graphing that I want to mention. Most of you, I'm sure, have plotted plenty of graphs before, but there are a few things, few details that I want to make sure that you remember and do correctly. Since the data has negative voltage as well as negative current, then on our grid, and I'm not going to draw all the grid lines, but we have the grid here, we're going to need to have the origin in the about in the middle. So it would be good to darken one of those lines across there to make that an axis, and darken one of these vertical lines to make this an axis. Okay? Then we want to label both variables, both axes, and I'm rather particular about this, so you need to label with the variable and the unit. We're going to plot voltage on the y-axis, so we have V for voltage, but also the unit is volts. On the x-axis, we're going to plot current. If you want to write the word, that's fine, but I usually just use the symbol. So we have current. Now, we can either do amps or milliamps, and I guess I don't really care. I think what I will do is put milliamps here, and then depending on your numbers here, at some point you're going to need to convert the milliamps to amps when we find the slope of the line. Another thing on this one, I think I did tell you to plot the voltage on the y and the current on the x. In general, when you're plotting a graph, if you plot y versus x, like you did in algebra a long time ago, the way to remember which one goes on which axis, or the way that I remember, is I read from left to right, y and then x. On a graph, if you look from left to right, you encounter the vertical axis, well, maybe not in this because of here. If you have, let's look at this. if you have a graph like this, you look from left to right, you encounter the vertical axis before the horizontal axis. So the first one mentioned goes on the Y, the second one mentioned goes on the X. Most of the time in the later labs, I may not tell you which axis. I'll just say graph of voltage, make a graph of something versus something. That way you'll know which numbers go on which axis. Okay, so then you're going to plot your points, and let me have an orange here. We'll see if it shows up. I'm purposefully not going to plot points that are quite like you're going to get. So if we see, I don't know, can you see those? Okay. If we have points, and since we had some negative ones, I might put a negative one or two here. Then if it looks like it should be a straight line, use a ruler or some kind of straight edge to draw a best fit straight line. Now, I'm not going to do that, but I'm just going to draw a line up here. Okay? So you draw the best fit straight line. If it's a straight line, then almost always you will be told to calculate the slope. When you calculate the slope, you should pick 2 points on the line that are not data points, and I want to emphasize that. You should not use data points. So I'm going to pick a point up here and circle it, put an X on it and a circle, and maybe one down here, or maybe I'll just put one in here. The 2 points should be somewhat widely spaced. Doesn't have to be like totally all the way across the line. But you should look for places where the line crosses the intersections of the grids so that you can read the numbers easily. The idea is that the line is representing the data. Now, in some of these, a lot of your points will be on the line, but the strict rule is you pick 2 points on the line that are not data points. And then, of course, I would assume you remember that the slope in general is the rise over the run. So you take the change in the vertical, and I'm going to actually write vertical and horizontal here rather than y and x. The change in the vertical divided by the change in the horizontal. And when you're calculating the slope, I would like to see the numbers, because if something is wrong, then I can tell whether you didn't read the graph right, or you did run over rise, or maybe you didn't push the numbers right on the calculator. So you should show enough of your work that I can tell what you did. Okay, so you're going to be finding the slope, and sometimes you may not know what the slope represents. Sometimes you might. So at the moment, I'm not going to tell you what the slope represents. When you're doing this, there's a couple of questions that will sort of point you in the right direction. But you still should use proper units. So at this point, I'm going to say you should end up with slope equals some number, and then the vertical axis was volts, the horizontal axis, and by this time you should have amps. Your milliamps, you should have already moved the decimal over so that you have amps in here. So this will be volts over amps. And then a step or two after this, if you figure out what the unit should be, if you want to go back and put it there, that's fine. But if you're not sure what this simplifies to, then you should at least use the units that the 2 variables have. Okay. Now we're going to go back to the circuit board, and the next part has to do with, there's a section in here about determining Ohm's law from the graph, and you should at some point obviously work through that. Then we're going to go back to the next part, which is investigating the behavior of a light bulb. So what I need to do is take out the resistor, and I'm going to put in a light bulb. You should have, I'll take this back apart, I think 2 bulb holders, and you'll have several little light bulbs. Technically, you only need, for the whole part, you need 1 number 48 and 2 number 41s, but I put an extra one in of each. Now, you have to look on the side, and I don't think I'd even try seeing this, but on the side there's a number stamped on the casing, and this one is a number 48. So you're going to screw this into the bulb holder, like so. And then it tells you, actually I don't think it tells you, it just says do this with a light bulb. So I want to put the light bulb here. So I have another little piece of wire, and you push this clip down and insert the stripped part so that it makes a connection there. Now you can also clip on here with the alligator clips, but I wanted to get this put into the circuit very similar to the way the resistor was. So actually I probably should have turned these meters off. Well, I'm just going to leave that. Let's just leave this one on. I'm going to just disconnect them. Okay, so this one is disconnected, and this is disconnected, and this one is disconnected. So these 2 go with this one, and these 2 go with this one. So I'm going to take out the resistor, put it over there. Now I want the light bulb to go there where that was. So I'm going to insert this wire in the same row. Be sure it's in the same row. And then I'll just kind of sit it there. And then we have our wire from the ground. So the first thing we need to do is probably reattach our voltmeter, and I think 20 volts will be okay. Positive on positive, and don't clip it onto the insulation, that won't work. You have to clip it onto the metal part. So we're going to do that. I'm going to clip this onto the other side of the light bulb. Then I need to insert my ammeter into where the circuit is disconnected or separated. So I want the black one to attach to the ground wire, so we kind of keep black with black. And then we need the red one to attach over, over here. I can actually just attach it to that. I could attach it to here, either one. The other thing that you have to watch when you're connecting all these circuits is that the metal doesn't touch where it's not supposed to. So like this one, I have to make sure that I don't get it over on top of that, because then that kind of messes things up. So I want to make sure things are not touching where they're not supposed to. Okay, so that looks fine. Now, you should always, before you turn the circuit board on, you should always turn the voltage knob fully counterclockwise so that it's down to a small voltage. Because we had this at 8 volts for the resistor. If you leave it at 8 volts and connect the bulb, it will burn it out, because it will only go up to about 4 volts and then it burns the bulb out. So I think I have things connected here. It almost seems like, okay, we need the ammeter. We're going to have more than 2 milliamps. Let me tell you this. I always forget this. There's a question here about the resistance of the light bulb. I think since I've got it in here, I'm going to leave it. But you should measure the resistance of the light bulb either before you put it in here, or if you do like I do, you can do it afterwards. You would just turn this thing to the ohms and measure across here. And maybe I'll do that in a minute. Okay, so this is going to have less resistance and we'll have more current. So we need this one down to the 200 milliamps. Now, if you don't get it turned to the proper scale, that's okay. It won't hurt the meter. It'll just show, or it won't show a number, and then you can turn it until it shows numbers, and that should be fine. Okay, let's turn this on and see what we get. Okay, so we do get about 50 milliamps. We see the light bulb is just barely on, which is good. The voltage is about 1.15. It says that we need to start at +4 volts, so I'll go ahead and turn this up. As we turn it up, you can see the bulb gets brighter. And when we get to 4, I'm not sure the exact limit on this, but probably 5 or 6 would burn it out, so we're going to just stay at about 4. So we have our voltage here and our current here, 96.1 milliamps. Now, it says to decrease in increments of 0.5 volts. So we go from 4 down to 3.5, and then to 3, and we keep going down. We get to 2.5, to 2, and then 1.5, and then the next one that we would try to get is 1 volt. However, we turn this all the way down and it doesn't go down to 1. So that's why I have a comment in there to skip any voltages that the circuit board will not provide. So you won't need to record anything for 1 or a half. Now 0 we know is 0, so you can still record the 0. I'm not sure if I said that or not. I think there's a space where you can record the 0. So we're down as far as we can get, and then we need to go to the negative voltages. So again, we will switch this. I think I will go ahead and do that. We can leave everything else connected and change this one. And then this one goes to the ground. And notice we should end up with about the same values that we had, except negative. So we've got a negative voltage and we have a negative current. And then we can increase this up to about 1.5, well, 1.5 and then 2 and 2.5 in increments of 0.5 on up to 4 volts. Okay, then the rest of that part is doing an analysis on let's just say answering questions. Now, another thing that I forgot to mention when I was talking about a graph, if some of you have your computer and have Excel or some other graphing software, if you want to use that, that would be fine. You should be able to print it out though, so that you can send the graph with your labs when you send those. Okay, so there's some more questions and some more things to do for that. I think, let me go ahead and take this out and show you about measuring the resistance. Okay, let's turn this down, turn this off. I'm just going to take these things out here. And I'm going to use the yellow meter. Actually, it doesn't matter which meter you use to measure resistance, you just have to get it on the proper scale. And I think it tells you to put this on the 200 ohms. So 200 ohms. Ohms is over here. Oh, it's down here. 200. There's 200 ohms. It's actually at the very bottom. You have to watch, there's 200 ohms and then there's 200 kilo ohms. So with the 200 ohms, we'll just clip across here. Well, if you hold it like this, you want to make sure that these metal pieces don't touch. So maybe turn this around like so. It'll kind of settle down about 4 volt or 4 ohms. So the light bulb should have a resistance of around 4 or 5 ohms, which is a lot less than our resistors did. Okay, so if you happen to not measure this back at the beginning of this part when it's said to, then you can do it here at the end. And I think that's about all that I need to say about this. So we'll quit.